here. Welcome back to the afternoon session. My name is Cheong Siu An. I'm an assistant professor with the Division of Physics and Applied Physics in the School of Physical and Mathematical Sciences here at NTU, and I will be the chair for this session. So to start off, let me recap a talk that was given in last year's Complexity Conference. Last year's theme for the Complexity Conference was called Hidden Connections, and of course we were actually celebrating Jan's hidden connections that allows him to bring so many of these fabulous speakers here together in one room. But one of the speakers last year was Harvard economist Ricardo Hausmann, and he talked about his work on the Atlas of Economic Complexity. That got a lot of people very excited because using the Google PageRank algorithm, many of the hidden economic connections could be brought to the fore, that we can actually see them and talk about them. After this particular conference, Jan attended an Institute of New Economic Thinking workshop in Hong Kong, where he told me that he was most impressed by Professor Pietronero's talk there. In Jan's word, Professor Pietronero's talk made the most sense in the workshop. And last June, actually, I had the good fortune myself to hear Professor Pietronero talk in the International Conference on Econophysics in Shanghai. And as I listened to him talk, so this is not just second-hand information from Jan. I actually heard Professor Pietronero talk, and I thought to myself, you know, this is amazing work. And in fact, later on, you'll feel how amazing this is yourself. But let me just say that I afterwards looked up his publications and found that he doesn't just work on problems related to economics. He's a physicist, so this breed of physicists are called econophysicists. But he doesn't just work on econophysics. He has been doing a lot of work on statistical physics, as well as superconductivity, condensed matter physics. And for a long time, he has actually worked on various other problems in econophysics as well. And I tried to look back at his publications and found that I think he started doing things like this many years before the Atlas of Economic History Complexity was actually published. And then in November, I met Professor Pietronero again in the matter of a few months. So between June and November, there's not that much time, but he has actually managed to delve yet deeper into the problem of the economic complexity of international trade. And I think this fits the emerging patterns theme of this conference very well. And at the same time, I was also started organizing the Asia-Pacific Econophysics Conference to be held in NTU in July, and I approached him to be invited speaker. He's graciously accepted. Those of us in Singapore can look forward to meeting him again, and I think even people in the government may want to hear what he has to say, but for now, let us invite him to share his insights into the economic fortunes of nations. Please.
Thank you very much. Thank you very much, Cheong. Yes, I know. Yeah, it's a great pleasure for me to be invited at this meeting, and I hope you will share with me some of these ideas and possibly have comments or suggestions or so. The field is very new. I mean, I've worked in economic areas on different subjects like agent models and so on, but this really arose with the paper of Hausmann in 2009. So I read this paper, actually I read it in 2010, and I found it intriguing. And so I told one of my students, Takela here, as you see the subject is now very popular. So Takela, I said, why don't you replicate everything that Ricardo Hausmann has done? And the idea was, I gave for granted that they would have done what one could do for countries and products. So my idea originally was to do it for companies. So this was, so I said, do it again, and then we try to move to another field. But in doing it again, as often is the case, I found out one can do it much better. And this much better you will see now in a quantitative sense. And so, okay, now this dragged us to do it again and to expand in other directions than Ricardo and so on and so forth. And that's what I tell you today. So the idea is to change the perspective of standard economics and measure things which do not refer to money, but to something intangible, namely how good you are, how good you are in terms of industrial competitiveness. And this we do in a bottom-up perspective, so in the spirit of Google, but, in this sense it is similar to Ricardo Hausmann, but you will see it is different also. And so let me show you a little joke. People think that economics is the dismal science, so one of our ambitions is to turn it into fun. And the fun has colors, and it has the font of the Google script, as you see, which is not by accident. And so what is the idea? The idea is not to start with dogmas, to start from empirics, as science usually develops. And then from these empirics, you look at data, you try to get inspiration, as somebody said today that Einstein suggested. I didn't know Einstein suggested, but every scientist who is successful in understanding something has to do it that way. After you get inspiration, you try to make a theory. Most likely it is wrong, so you have to go and check again the data. Then you try 2 or 3 times, and finally it begins to make sense. This is how science works for everybody. And so we try this approach. This is very different than how economic theory works, because economic theory is typically top-down, so you define a dogma, for example, the rational agent or something like that. Then you draw dogmatic, or if you want, axiomatic consequences, like Aristoteles, and at the end, you only look for those data that fit for these things. I mean, this is how we have seen the consequence of this approach with the crisis and many other problems that have standard economics. But in any case, I don't want to do like many physicists or other people who just try to say everything is wrong in economics. I don't know. I mean, you judge yourself. We try to do something constructive. We take data and get some information. How much this is against, in favor, etc., is up to you. Okay, in this sense, we are technicians. Okay, we don't do much philosophy, but try to solve a problem. Now, what comes out of this, how to say, rather ambitious project? It comes 2 new links. One link, if you start from the bottom, you have a lot of details. So you have heterogeneity of the structure. You have the structure of all the products, all the countries, a lot of details, okay? In principle, also the companies that will come later. And then you go up to a large scale, to macro, so you have the GDP, but only at the end, and you have the GDP constructed from the details of all the products, which is not what is usually done. So this is a link between microeconomics and macroeconomics. So microeconomics usually deals with companies and individual products, and macroeconomics deals with countries and GDP. And here you will see we do precisely, we develop such a link. The other thing that you see was curious to me talking to economists is that to me economics and finance was more or less the same thing, having to do with money. Okay, I visited people in economic theory departments, but also in finance companies and so on, without posing too much problems. And then I found that my economic professor colleagues, they were very surprised of this, how to say, relaxed attitude that I would go everywhere, because they say, why do you go to finance people? I mean, that has nothing to do with economics. So I learned that finance and economics are completely disjoint. And why they are disjoint? Well, because one of the axioms, of the famous axioms, is that the price contains everything. So the price of a stock, the idea is that out of the 6 billion people or more that are around here, well, everybody knows the right thing. I mean, some will know what is important to know, okay? And they will use it to trade. So in a way, the price is the synthesis of all this information, which is infinite by definition, okay? Now, if you believe into this, you should just leave the room and have a little walk, because it will be more interesting than my talk. Because this means that I cannot give you any new information which is not discounted in the price, okay? So since I think that what we do, we try to make it interesting, then I think it is not true that the price discounts all the information you can find if you make a nice story in economic theory or whatever. So the additional link, in addition to the one microeconomics, macroeconomics, is new information in macroeconomics must have something to do with finance. It is possible that some smart guy with different tools or with intuition and so on reach the same conclusions. But as you will see, economist opinions, since it is not a science, so to say, they are very broad. So the majority, I mean, many people, we have different ideas. Some people may have the ideas that I will show you, but not all. And in some cases, the majority has the same opinion. In some cases, the minority. So certainly it is not true that everybody has full information, and it is not true that the price discounts everything. So we try to argue that in some cases, our new information has also implication for finance, because finance, after all, is information. This is the outlook. So since I want to go straight into the matter, I will show you now a specific question. What is the standard approach? What is our approach? The specific question I will take is the one of the possible industrialization of sub-Saharan countries. So I was at this nice meeting a few months ago, and there was a talk by Dr. Ansu, who works in Ghana and in Washington, and he made this very big report, and the question is, will sub-Saharan countries have a chance to become industrial like Vietnam, like, okay, Korea is now very developed, Thailand, so countries which are halfway industrialized. So what is the chance that in the next 10, 20 years, sub-Saharan countries, which are now very poor, will become a little bit industrial? Very relevant, very specific question, okay, very important. So what you find in this report? In this report, you find a lot of data. Data of this type. There is no need, this is just for your visual impression, and there is no need to go into the details. So here is GDP growth per capita, okay? The blue line is this GDP growth averaged over 12 sub-Saharan countries, and the green line is the same thing for early developers like Vietnam, Korea, Indonesia, and others. And then you have many more. Okay, I only show you 3 pages. There are more than 50 pages of this type. At the end, you know everything, because you have all the possible data. You have big data in front of you, 50 pages of this stuff. But you also know nothing, because what's the conclusion of all this data? So if you don't have a rationale to go into the data and make sense, for example, somebody may think that this data is more important than that, or that these two are the same, or that one is wrong, okay? So you see that even though you have a lot of information, incoherent information is very confusing. So the result is that it takes 50 pages to discuss this data, because everybody may have a different opinion. Now, some will have the right opinion, but certainly it's not unique and is not something on which everybody agrees. This is a typical situation of macroeconomics. You have lots of data in front of you, then the data are, so to say, flat. They have no structure. The structure is given to the eye of the observer, and then each observer gives a different structure and therefore gives a different result, okay? So I went home to these guys I showed you before the list, and I say, okay, guys, let's do the same with our tools. And the result, instead of 200 pages, 1 page. Now, here is GDP per capita, and here is our little magic new variable, which I call fitness, and I'll tell you in a minute how it's computed, but this is basically how good you are, okay? So the natural development is that, you see, first you become good, and then you become rich. Okay, this is the typical situation. You will see a lot of this stuff in the future. But let's start with the sub-Saharan. So these are the trajectories of 12 countries, which are the sub-Saharan countries, over 15 years. And these are the trajectories of the so-called early developers, exactly those of Dr. Ansu. Now, you see, the conclusion is that the two groups are basically disjoint, with the exception of Kenya, Senegal, and Uganda. Okay, this is the result. Nothing to discuss. Okay, now, this is what I mean by pre-scientific, lot of data, incoherent, and scientific, one specific result. Of course, the result is scientific, but it can be wrong. So now our concern is to check whether it makes sense and so on. But at least this is the type of transition I would like to propose in this and many other fields. And okay, so the question is now how good it is and so on and so forth. So what do we do? How do we measure this magic fitness? We start with the information which country produces which product. So these are products in the 4-digit classification. So this is not money or so. It's just the name of a product. So this could be cars, this could be the iPhone, and so on. This could be textile, etc. So where do you get this data? This data we get from Comtrade, from the export. But the export is not that we care for export. The export has the advantage that the data are unified in terms of with the same variables. Because now, indeed, we want to do a little bit like Google, so we need a uniform classification. Unfortunately, these data today do not include services, which is an important element, for example, for Singapore, but also for other countries. And this, we are improving the data accordingly. In the next months, we hopefully will have also some glimpse of what the services do to this data. But so it's mostly manufacturing analysis. And, well, however, I just heard a talk 2 weeks ago that in many ways, high-level manufacturing is very correlated with services. So in some sense, even though you don't know services, you may know quite something. It is like this. Suppose I can visit the house of somebody, and this house has 10 rooms, okay? And I have to decide how good he is, or how rich, or how wealthy he is. And I can only visit 7 rooms, okay? You see, it is unlikely that those 3 rooms I don't visit contain a treasure, okay? Possibly. Actually, with Singapore, it's a bit like this because there is a treasure in the services of Singapore. But in most cases, visiting 7 rooms out of 10 gives you a pretty good assessment of the situation. But we are fully aware of the limits of the data we have and of what we do, and certainly it is our intention to improve on this. So in many ways, all the data you see are weighted towards manufacturing, okay? Now, why we don't have to do the report of 200 pages? Well, because we use a logic that is the elimination of data, not the addition of data. And why we do this? In principle, we have 3 sets of data. The countries, which is clear what it is, the products, which is also clear what it is, and the capabilities, which is what I call the intangible. What is a capability? Well, capability is, for example, education, transportation, justice, pollution, etc. Now, if you sum all information you have of capabilities and of products, you have the report of 200 pages. But then the question is, what do you do with all that stuff? It's very difficult to make sense. So we decided to be, how to say, lazy, and we eliminate a lot of data. We eliminate the capabilities because that's what we want to compute. That may appear funny, but the idea is that, you see, all the information, the integrated information on capabilities, which we call fitness, how competitive you are globally, and their interaction. Because if you look one by one the capabilities, you may have, you know, that you have to sum up education minus pollution. But how do you do such a thing, you know? And so on. So the idea is that you take the integrated effect, and this is reflected into the products. This is so a little bit the products discount all the capabilities. I've discussed with the company of a famous economist, Professor Rubini. He has a company a little bit in New York, a little bit in London. They try to do exactly the same of what we do now. And of course, they do it in the traditional way. They go through the capabilities, and they study the level of education of Singapore, transportation, all this, and they have between 100 and 150 parameters for each country. Now, it is clear that this gives you some information, but you can imagine that the degree of arbitrariness is also very large. So in our case, with this idea that with the smart analysis of products, you get the integral effect of capabilities, we have data. We have an algorithm, which I'll show you in a minute, and we have 0 parameters. So there is nothing we can touch, okay? It's there, fixed. So this is there. Now, of course, being fixed, as I say, can be right, it can be wrong, but you can improve it as a fixed scheme. And so it is scientific in the sense there is no parameter. So basically, we look only at this data, which are much less and much more clear, with the idea that from this data and some smart analysis, you get the information on the blue stuff, okay? That's the idea. Now, clearly, this shows that big data can be very confusing, okay? So the biggest success of big data is clearly Google, because you have a lot of data, you have a very smart algorithm, and you make the page rank. Now, here, I will try to argue that each set of big data requires a different algorithm. So my view is different from Hausmann in the sense that in economics, the Google algorithm is not the right one. And for companies, it will be another algorithm and another and another. So my idea is that Google is not the answer of everything technically. It is the approach which is in spirit analogous to Google. But we develop an algorithm because optimization is different for a country, for a company, and so on. For example, let me show you how the data look like. The data look triangular, which means the following. Here are countries, top countries are up here, top products are on the right, okay? So these are the most sophisticated countries, most high-tech. And then they do the very high-tech products, but as you see, they also do essentially many other products, very simple ones. So it is not true what the other David Ricardo said 100 years ago, that each country should specialize on what it can do best. It is not true. Each country does what it can do best, but it does everything else up to zero complexity. Now, this is a fact. And so as you see, we look at the fact, we disprove a well-known theoretical axiom, which is this of specialization of countries. And then from this, we try to induce some algorithm inspired from the property of the data. This is how we work. Now, Mr. Ricardo was not so stupid, because his argument of specialization is actually correct for companies. So for companies, the argument of diversification is not right. Companies do specialize into a few products. So if you pass me a metaphor, I would say countries are like a forest. There are lakes, mountains, animals, plants, a big ecosystem. And so for the stability of this ecosystem, you need a certain type of optimization. If some animal dies, it doesn't matter for the ecosystem. But if some animal dies, it matters for him, you know. So an animal is a company is like an animal. So a company has to survive itself, himself, herself, okay? It doesn't care, I mean, it cares about the ecosystem, but the thing is, it has to eat before tomorrow. So the optimization of the country, which is what I will tell you in a moment, is completely different than the optimization of a company, or the criteria for optimization. Therefore, the algorithm which we will introduce here will not work for companies, and today we do not know the algorithm of companies, nor what is the optimal data set. So you see, my view in this is very different from Hausmann. You have Google, which works for PageRank, for the internet PageRank. Then we have the ecosystem of economics, which goes from country, very big macro level, to companies, so to say, small local level. And the two objects are part of the same system, but with very different optimization criteria. So now I show you an algorithm good for the global ecosystem of countries. Tomorrow, I hope, I'm not sure in June, because it's not so easy to do the algorithm for the countries, also data are not so clear. But I hope in some time to have a third algorithm for the companies. And tomorrow, maybe we have other, you know, the startups and so on, which will require new algorithms. So my view of big data is that big data should be divided in categories. Each category has its own optimization criteria, and for each optimization criteria, one has to develop a specific algorithm. And this is very new because everybody up to now has tried to just use Google whenever was possible, which is where I disagree. So, of course, our task is to move from these qualitative statements into quantitative analysis and introduce metrics. I mean, metrics, not metrics. What we would like to have finally is that we have two pieces of information. Money, how much money you make, GDP, and intelligence or capability, global capability, which we call fitness, how smart you are, okay, in producing industrial-wise. So if you have oil, that's not very smart, unless you have to refine it in a very specific way. So out of this gradient, we get new information, which has a lot of uses. For example, suppose that you make this argument for an artisan, okay, a guy who produces some furniture. Then you visit him, you see how good he is, and you find that with respect to the guys who are as good as him, he doesn't make much money. He has more capability than reward, than revenues. So you can predict, given this gradient, comparing with others, that he will make more money in the future. Okay, so that's how this comparison gives you information that can be used to make forecasting. On the other hand, if you see that somebody is not very good and makes a lot of money, either he has oil in the ground, which, okay, then is that the reason, not his capability, or is, I don't know, doing something strange, like gambling, playing the roulette of finance or stuff like that, as Iceland was doing for a few years. Okay, so you see, finding something non-monetary is very important to define a gradient. Now, this is the algorithm, and I try to tell you a few words since we have especially long time, I appreciate, so I can go into some detail. How do you build such a story? Well, this is the fitness. It's an iterative algorithm, so you start with 0. Okay, what would be 0? 0 here is power 0, so you eliminate Q. MCP just tells you yes or no. Do you produce a product, yes or no, more than some reasonable amount defined by economists. So this is a 1 or 0, so you basically have the sum of all the products you make to the 0 level. Of course, to the general level, when you also know a little bit about the complexity of products, which will come next, then you say, okay, it is good that you make many products, but when you make also the good ones, it is better. So F has 2 elements, diversification, this is the sum of everything, weighted by complexity or quality, okay? That's the idea, very simple. But this is already very different from Hausmann and Google, by the way. So if somebody wants to discuss this, I have time later. Now I don't go into that much technical details. But the more sophisticated is the question of the complexity of the products. So in first approximation, what do you want the mathematics to describe? Well, a product is of low complexity if everybody is able to do it. Okay, what does it mean everybody is able to do? Is 1 divided everybody. You see, this is, forget this for the moment. But if you have just this is the sum of all the countries that make a certain product. So the more people are able to make a certain product, the worse is the product. On the other hand, if a certain product can be made by, for example, I don't know, Germany, okay, well, it doesn't tell you much. You know, Germany is very competitive. It does everything. So, but if this product can be made by Nigeria, this is much more information. Then it must be a simple product because Nigeria has a limited capability. So we have to make so that the worst, the more a country is limited in its fitness, and the more it contributes to this denominator. So you see, that's the reason of 1 over F. So because if F of Nigeria will be very small, it will be 1 over 100. So when you have 1 divided 1 over 100, here you get 100. If you have F of Germany, which is 5, here you get 1 over 5. So the denominator, if a product is made by Germany, the denominator only gets 1 over 5, 0.2. If it is done by Nigeria, the denominator gets a tick, 100, okay? So this was the idea of building this formula. So I want that the product is penalized if the product can be done by a country with low fitness. This was the idea, very simple. Okay, however, simple ideas transform into non-trivial algorithm, because this algorithm, for those who have a mathematical bent, this is a non-linear algorithm, so it's completely different from Google, which is linear, it's just diffusion Google. So non-linear algorithms are rather more complex, can give rise to instabilities and so on. So the study of the convergence of the algorithm and its fixed point is not so simple, but it can be done. We have written a couple of papers precisely on the mathematical properties of the algorithm. In any case, the thing is pretty regular. But one could say, okay, but this thing you have just invented. I mean, I could put here power 2 or a square root. Why not? Well, the idea is first do the simplest thing. If the simplest thing works, then you can improve it. If the simplest thing doesn't work, I don't believe that an improvement will make it to work, okay? And also you can argue in a little more sophisticated way why you should write first the simplest, because I would say things are locally linear if they are analytical for mathematicians, okay? But so that means that in principle one could conceive more complex algorithms if one would have a very good benchmark. So if we would have extremely good data, very sophisticated, we could optimize the algorithm and consider a broader one. For the moment, we are not in this position. And this is the best one can do today, but tomorrow it is possible that we may do better. Just to give you a pictorial representation of what the algorithm does, you see, you sum up all the products that you make, weighted by the complexity. Of course, the complexity is already the result. This is written now. But what about the more complex part, the complexity of the product? You see, if 3 sophisticated countries make computer chips, you make one run of the algorithm, you get that the computer chip has a high complexity. The average complexity is 1 by definition, and the average fitness is 1. That we do by definition. So everything is relative. But then you see, these 3 countries, the same countries that made the computer chip also make nails, okay? So in principle, you say, okay, nails, they are made by USA, Germany, and China, so they are like the computer chips. Not quite, because nails are also made by Nigeria, whose fitness is much lower. So with this trick of 1/f in the algorithm, we get that Nigeria actually dominates the information on this product because it's the lowest fitness among these 4. And so the nonlinearity makes it so that the complexity of nails is very, very small. If you use the Google or the Houseman, then you would sum up Nigeria to the others, and you would get essentially the same number as here. I mean, maybe divided by 4 instead of 3. But basically, this doesn't add anything, but you have the big number given by these 3, you see. So this would be linearity, which would be Google. So my point is that economics does not work like Google, simply because of this simple effect that if something can be done by a low-level country in terms of fitness, who cares that it can be done by Germany or by USA? There are more things about the difference which are technical, so I don't go into that. But for those who are interested in this mathematical or specific mathematical properties, we wrote a very long paper in 2013 to discuss the various algorithms in great detail. And everything is in our web page. So you go to Pietronero on the web, and this economic complexity, you can find all these papers. So what can we do with this? So the game is very simple now, okay, if you believe the story. So we have eliminated a lot of data, only focus on the products. We have defined an algorithm, we have 0 parameter, so we push the button of the computer and get the results. That's how it is the game, okay? And what can this button do? Well, we have done in detail countries and products, so this is the part which we have done at the beginning. We could do subsystems, regions, districts, cities. I mean, even a big city has a lot of areas, and it can be more or less competitive. For example, the question is, does it pay to put in one region all the products of a certain type, or it pays to diversify and things like this? These are important questions that we can try to answer. So at the moment, we are discussing with Alibaba, the big e-commerce company of China, to make an analysis of the China area. So we take China as if it would be the universe and analyze region by region what is the fitness of each region, and then try to optimize or predict the growth, but also optimize the structure for industrial planning and other things. So these things, as soon as you give me the data, we can do it in no problem. And one could also go into industrial sectors and so on and so forth. Then there is a line here, you see, a very strong line. This is what we cannot do. We don't know exactly which data to take, and we don't know which algorithm should be used, because companies are different from products in terms of their somehow ecosystem role in the ecosystem. So companies should be specialized. So in terms of products, you have, that Apple and Samsung, well, Samsung does a lot, but Apple produces very few products. Everybody who does the same produces the same products, so there's no information. So you should look for different information. For example, what are the technologies they control that you can get from the patents? This brings you into a rather complex story of patents, technologies, and so on, which we still didn't dig out really the root of it. But that's what, for us, is the new frontier. So this is the part. So now, you remember when I showed you our one-page result for the Sub-Saharan, I said, okay, this is scientific, but it can be wrong, as many scientific propositions. So we cared a little bit to try to check whether it's right or wrong. So following the argument I gave you on the algorithm, on the capabilities and so on, you can show that the diversification you observe in the data straight from data you get, how many different products you make, can be related to something like an efficiency. This pi is not 3.14, it's an efficiency, with an exponent which is sort of the fitness, okay? So you compute the fitness, which should be F actually, and you check with diversification. If you find that these two things produce a single line and not a big cloud on a piece of paper, the more they define a single line, the more the whole thing is consistent. So what you see is a visual test of the consistency of our algorithm, which is, it shouldn't be necessarily linear. The line is just a guide to the eye. But so this shows that there is a reasonable, consistency, but maybe one can improve it a bit more, okay? So this is a test. So the consistency is in as much as things go along a single line, this is consistent. They should go if what we say is believable. So this means there is also a margin of improvement. Just to show you what the same test would give for Google or for the Hausmann algorithm, you see that's what you get. So because in my opinion, this is much less consistent. You cannot use Google for economics. And so you see you get a lot of noise, and this noise would prevent you to obtain most of the results I will show you now. So you need a certain accuracy to see, for example, to see a change of profile. Now, this is our data extended to the left to the so-called poverty trap. So as you see, this is industrial economies, which are very complex economies. This is simple economies, subsistence economies. So what you see, this line is very steep. And imagine that you are here in fitness, you invented the laser. So with the laser, you move from here to here, okay? And now you move from here to here, you develop many more products, because in a complex economy, if you make an invention, you can use it in many, many products, okay? Now here is much less steep, it's almost flat, because if you only grow 2 potatoes and eat 2 potatoes, if you become a little better and you make 3 potatoes, it means your belly is a little thicker, but you're not going to become industrial economy, okay? So there is a marked difference between the two trends, and this point, this crossover point, identifies the level of fitness in a quantitative sense that permits you the crossover from somehow from subsistence economy into an industrial economy. Now, this is a very important point because, people have been talking about the poverty trap a lot, but this approach, defining the fitness, permits you to define a quantitative threshold for this, which you can use in industrial policy. Suppose this is Angola, and you want to see how far we are from industrialization, well, you know that you are this far, okay? So if you make for Angola a plan to go from here to here, you better forget. I mean, you are wasting your investment, okay? As well as if you are an investor, for example, it may be interesting to invest on the countries which are near this kink, because these have a chance to go up the steep route, for example. So this is the typical thing. You can use this for planning and for also for information in finance. One of our early results where we disagreed with the standard view was the analysis of BRIC countries. BRIC countries is the acronym of Brazil, Russia, India, and China. And this acronym was defined by the president of Goldman Sachs in 2001 as the 4 countries which will dominate the world economy for the next 50 years. Today, people criticize this concept, and they think it was totally unmotivated, okay? But we could have said this a long time ago, because if you only look at GDP, there are 4 total GDP. 4 countries are very similar, okay, and you can argue other things are similar. But if you look at the fitness, namely how good you are, you see already 10 years ago, you would have argued pretty confidently that China is extremely strong, actually is even stronger in potential than in money. These are ranking, however. Then India is pretty good and keeps a high-level position, but not growing much in fitness. And then Russia is very bad, and Brazil is also rather problematic because both are too much based on raw materials. So this is an example in which you see that opening up a new window, the window of the fitness, somehow gives you a totally different vision of a certain situation. And in this case, I think we were right. I mean, because now people agree that that's the situation, but they agree now. We could have seen this 10 years before. The most important slide I show you is this one. Here we are in 95, GDP fitness, okay? Now, this is sort of average, and here you can guess what happens. This is China in 95. You remember in 95, China and Brazil were considered similar, at least to a non-expert like me. I mean, there were equal chance to grow for China and Brazil, roughly speaking. I mean, nobody was thinking China would develop so fantastically, at least from the ordinary newspapers I was reading. But you see, Brazil is here in the middle, but I don't even possibly is invisible here because it is printed on top. But China is certainly different. It has a very big value of fitness, very large fitness, and very small GDP. So we are exactly in the situation which China had a lot of potential to develop. And in this sense, this is a forecast also. So the prediction here would be that China will go up very steep, as you will see in a moment. On the other side, we have oil producers, which have a small fitness and large GDP, and that's because they have oil. Fine. Good for them. But here is Iceland, which is even higher and doesn't have oil. And they were gambling with the financial derivatives. So the message here is that if you are here, you are a candidate for fast growth. If you are here, either you have oil or you are a candidate for bankruptcy, okay, as it happened to Iceland a few years later. So that's how to read this diagram. In the next diagram, I show you all the little spaghetti of the trajectories of this country in the following 15 years, so from 95 to 2010. Look at China, because here you can see clearly. The others are a little messy. China, you know, went up very, very steep. India also a little bit. The rest is difficult to see with the eye, so I help you with this trick. So I take little boxes, and the arrow is the average of the trajectories that go through a certain box. So in physics, this is called coarse-grained analysis. And now you emerge, you are emerging meeting, it emerges a new property. It emerges that from this data, that in this green region, you have a laminar flow, so you have flow with the stationarity properties, and here you have chaotic flow. So if you want to make predictions, you can say that here you can do reasonable predictions, here you cannot do reasonable predictions. So in terms of dynamical system, you can say that in this area, the two variables we have are enough to define the behavior of the system. This means that the other variables are irrelevant. So for example, by observing that here you have a laminar flow, I can tell you, without knowing anything about corruption in a country which is here, I can tell you that for that country, corruption is irrelevant for its economic development. And I know nothing about it. But why I can say so? Because this shows that these two variables are enough to define a regular flow. So if corruption would be important, you know, this couldn't be regular in a way. On the other hand, if you have corruption here, then you have to watch, because at least with respect to economic growth, this is not an ethical argument, because there you may have a big problem of other variables like corruption, politics, and so on. Okay, now a big question that was made to me a few days ago by Joe Stiglitz was, you know, can you extend the number of variables and make it so that this threshold is pushed to the left? Okay, interesting question, but not so simple, okay? Now, the extension of the variables is a typical suggestion I get from many people. Of course, you know, it's always good to extend things. The problem is that if you extend it too much, you get confused. But I think an extension which we will try was suggested by Royal Dutch Shell of the Netherlands and UK. And Shell would like to add a third variable, which is energy content of products. This probably we will do, okay, together with them. So there are many suggestions, many ideas. A similar, I mean, the same data can be mapped with a different program. It's the same data. I like this more. It really looks like the flow of a river. Okay, and here you can see this is laminar and this is turbulent. We made recently a Hollywood approach to this problem. So we have a little movie, which also appeared in Nature, in an editorial of Nature. So you can see that here, after a while, countries become very, very regular. You see here is regular, and here is not. So this is a visual view of what we have been talking. So this appeared in, it's finished, the movie? Okay. I don't know whether we get the Oscar, but in any case, I hope you like it. Okay, you want to see it again? Okay, I will show you, because maybe first you have looked at certain things, now you can look at the other side. You see these large fluctuations you see here, you see here large fluctuations, yeah, you see this guy. Okay, this you shouldn't take so serious, because if you are on the left, you see, this means fitness 10 to the minus 2, 10 to the minus 4, 10 to the minus 6. So you see, these countries are extremely sensitive to small changes in the data. So these are, in any case, this is a log scale. So I would say on the left of this line, this whole thing is basically chaotic, so one cannot really trust. If there is 1 year that you get a new product, yes or no, this can change the fitness by a lot. In any case, are very small numbers. So essentially, you can believe in this story from this zone on, okay? And then you see this becomes, so it becomes regular. This was discussed together with Hausmann and Hidalgo a few days ago in this Nature editorial, which was written because of our paper on these flows, which appeared a few days ago. But okay, we can look at an example. For example, Korea is a very nice example. This is the development of GDP versus fitness of Korea from 63 to almost now, 2000. As you see, the development is not at all like Piketty describes, namely something like always the same. You can define two different regions, at least. So one in which you increase the fitness, but you don't make any money, so you invest. And another in which basically you don't increase the fitness anymore, or almost, and make a lot of money. Now, in terms of Piketty, this is typical situation. So in terms of Piketty, this opens up a new situation, because the idea whether wealth should be more or less uniform is completely different in this regime and in this regime. For example, it is natural that in this regime you seed, so it is good to have more uniform distribution, because you put a lot of seeds and only some flowers will grow, not all the seeds will lead to some plant, okay? But once you have big companies developing, like Apple, Google, or Samsung, whatever, then this company make a lot of money. So it is natural that this regime has a sort of diversity in wealth, and that this regime has a more uniform situation. So this opens up a sort of more complex vision of the Piketty stuff, which is just a number. Okay, this is just a comment to something which is very popular today in economic theory. Just a few more comments on what you can do with this type of diagrams. You can analyze, for example, yeah, you see poverty trap now is here. You have the so-called middle income trap, in which the top of the middle income trap is Russia, Brazil, and South Africa, for example. And here you have fully industrialized country. This is Singapore, for example. I will have some specific on Singapore. Now, the typical argument today in economic literature is whether China will be able to exit the middle income trap. Okay, this is the argument. And most of the observers are negative. There was, I think, an article on Wall Street Journal, or some of these famous journals, that the title was, "What goes up must come down," which is not very optimistic, and it referred to China. So the argument was, China today is in the same situation as Brazil 15 or so years ago. Why they say so? You see, for us it's not, but for them, Brazil is here. 15 years ago it was here, the GDP. GDP of China, you see, is where Brazil was some years ago, okay? So the argument is, so it will do like Brazil. So after some years of growth, it will basically stop, and we'll have many years of static, more or less static situation. Now, this is a point where we sharply disagree, because this argument only takes into account one variable, GDP. And in terms of GDP, China is in the middle of the middle income trap. But if you add the fitness, you see China is not at all in the middle income trap. So the question for us doesn't pose. China is following a different trajectory. Actually, is more similar to Japan. Japan was more or less this line. Now, I don't have a specific Japan, but China is now much more similar, in our view, to Japan than to Brazil some years ago. So this is a point in which our analysis disagrees with the majority of the opinions of economists, because they do not have the fitness at all. And you see, here is not a matter of specific calculation. China is so much larger in fitness that even if you compute it a little bit different, I mean, it's a macroscopic view difference that, in our opinion, I think this is a strong position that I feel to take. So this story that China is like Brazil 15 years ago, I think we just disagree. How do you make predictions? I mean, you study the floor, basically. So you look at, given a certain box, suppose you are here, you are a country which are here, you look at the countries which have passed through this box in the past, where they ended up, for example, after 5 years. So 2 ended up here, 1 here, 1 here. So you can check in the laminar, in the turbulent region, you see you end up into a broad distribution. In the laminar, you end up into a narrow distribution. Still with some fluctuation, because there are forerunners and backrunners. So if you do this as good as we can, you have this type of information that, you know, given this trajectory, we expect, given what all the others have done, that this country will arrive at this point. And this cloud gives you the error bar, so to say, so the risk associated with this prediction. So this is a good country, for example, for us, where these numbers are reasonable. This is another good country. You see, this should go here with some fluctuation. This is another good country, and this is a bad country. A bad country because it is close to the chaotic regime, you see. So you can do this essentially for all countries, and well, this should have some predictive and financial value as well. Then you can look at the opposite part, the risk, and you see these are the countries which had the major downgrade in the rating in the past 15 years, and they are almost all left of this diagonal, except Egypt that had the political revolution. So, of course, the situation is different from the growth, which is here. Some countries are missing because they don't have a rating, but the growth is here because the risk is irregular. So, you know, we could say that Iceland was at risk, but you cannot say which year this risk will become real, will become a collapse, okay? So risk is erratic when it happens. Growth is smooth. We can look, up to now, you see, we compute two things. We compute fitness of countries and complexity of products. Usually, I never talk about the complexity of products, and even today I will talk only a little bit. But at the beginning, so this is old data, this is the complexity of sectors. For example, agriculture is this black stuff, all agriculture together. This is the behavior over the years of this complexity. I think now we can do this better, but I show you, because I want to show you another slide now. So basically, this shows that agriculture on average is below 1, which is the average complexity of products among all products. But now you can split agriculture into subsectors, specific agriculture, and you see you have that when you split it, some agriculture is very sophisticated. This is high-tech, and this is the simple one. You see, I know nothing about genetic agriculture. This is just from the statistics of this information. You see, I don't have any direct information that this is high-tech and so on. It comes out from the algorithm. But now, you see, we may try to do with the complexity of the products, and this is the first time I show, we may try to do something like this. So we put, for example, the complexity of products here, and here we should put some money. Which money? Well, how much money you do if you produce a certain product. For example, it is clear that if you produce a simple product, like a shirt or something simple, you make, added value is small. If you produce an iPhone, added value is a lot, okay? So we try to make the same. And then you can make arrows and things also for these products. So what happens? This is the very first time I show this. So we have defined a way to argue what is the added value. How do we do this? There are many ways to do. So we have done it in a way I tell you. If you have other better suggestions, welcome. So we do like this. We say, okay, take, I don't know, pens. That's a product. We take the pie of the volume of pens in the various countries, okay? Then for each country, we check the average GDP. And then we associate the added value to the pen to the weighted average of all these GDPs. So this means if the pen is only made by very rich countries, it has a large added value. If it is made only by poor countries, it has a small, and so on. Now, this is a simple way you can do straight. There are other ways. But the idea is that this would be the money you make if you produce a pen, the added money. Now, there is a sort of average here, and then there are very clear arrows over time. So let's consider this region. This is a region in which the complexity of the pen, for us, is very high, but the money you make is very little. So for some reason, this product is under-considered. So you expect that in the future, the money you make with the pen will grow, okay? Conversely, if there are products which have a low complexity, and they are paid too much, so there is too much somehow added value, it is likely that this added value will decrease. Now, this is the very first time we do this, but we believe that this also can be used in many ways. So there are products that are, so to say, under-considered with respect to their real value, that for us is Q, the complexity, and products which are over-considered. And somehow, this information can be used to see the flow, how this product will flow in this diagram. Now, we did recently also something else, which I just discussed with some person just before this talk, which is, not just which products you make, but which science you make, which research you make. So instead of taking countries and products, you take countries and scientific fields of activity. There are international data on this as well. So the first thing we checked was this famous diagram, that the more you make research, this is the citation count, is a measure of how much research you make, and the more you make money, but this can be read also in the opposite way. You must have a lot of money to make useless research. So this is not obvious which one is the right one. But okay, that in any case, there are other methods to argue in positive. So you remember an important element was that the countries to products was sort of triangular, this matrix. Well, also this is triangular. And triangularity was the basis of our mathematical algorithm. Now there are two things. One is extensive, so how much research you make, and this is intensive, how much research you make per dollar. Okay, forget for the moment, this is a technical. So in any case, given that it is triangular, it means diversification is a value, so if you make, and you can use the same algorithm. From this algorithm, you make a ranking of research fields and of countries. Now, this is very new. I don't want to spend too much time, but it is, there is one paper published and many more to come. But here, this would be the embryonic process of innovation. So at the beginning, you do research. After some years, you do the products. So the idea is to link this new result on the research that countries make to the product that we have discussed extensively. And this would be one way to look at innovation. On this, we are submitting a European project together with also well-known economists like Mariana Mazzucato and others. And the idea is to make a story of innovation using this type of data. You can go a little more in detail with respect to the fitness and define a spectroscopy. So here you put all the products ranked in terms of their complexity. So these are highly complex, medium, and simple. And then you put the volume. So Germany is #1 in the world in our fitness analysis. As you see, Germany has a very compact spectrum with a lot of weight on the high tech. Okay, these are the two things which are optimal in our formula. You can see, for example, now the BRIC countries. Of course, The fitness is just a synthetic number to represent this diagram. And now the diagram tells you a little more. So let's look again at the brick. You see China is almost as good as Germany, it's just number 2. And India is a little bit less. But now you can see that Brazil and Russia are completely different. You see, this is Brazil and this is Russia. So the industrial structure of these 4 countries is completely different. Even more different is the oil producers, for example. And now, finally, this is Singapore, okay? Now, Singapore ranks 22nd in the world for manufacturing. So this does not include services. So if you put services, probably would go in the top few, very few. But even though manufacturing shows some areas which are very high level. And especially, the whole thing is made that country size doesn't matter. But of course, there is a limit to it. And Singapore is at the threshold of this limit. So a little bit country size may matter, okay, in this case. Because if you are small, you cannot do everything by definition, okay? But all the variables we have are independent on size. They are intensive, so per capita. However, there is a finite size effect that if you are small. So this can be cured with appropriate tricks. So you can say, for example, suppose a country is small but competitive. Then it will focus only on the high-level products. And then you can say that if you are able to make a very sophisticated product, you are also able to make the same type of products which are in the same hierarchy, and you don't do because you optimize in the sense of Riccardo. So there are tricks which, if one wants to study specifically a relatively small country of high competitiveness like Singapore, this could be done. But it's especially tailored situation. You want to see, with respect to mostly manufacturing, what will happen to Singapore in the next years. You see, we expect it to grow at a rate slightly above 5% a year in the next years. This is only with information on manufacturing. Probably this is one of the countries in which the services will modify this information a lot. So we will do it in the future, by the way. This has been the trajectory of Singapore in the past years, as you see, only for manufacturing. So Singapore is number 20, so it's not up to Germany or so, which are here, but certainly it had the development and a fast growth also in the manufacturing. Much more can be done if you want to do this. One can go one step, and then I try to conclude. Still a few minutes. It's okay, the time? Can I go 5 minutes more? Okay, I thought 1 hour is usually enough for any talk, but so, okay. Now, with the particular argument, you can build the product space. What does the product space mean, or statistically? It means that if a country makes a pen, very likely it makes also the pencil. Okay, statistically what happens? That you will find that many, many countries make pen and pencil together. Okay, so by looking at things like this, you can build a tree of products. You can define that pen and pencil are nearby, while pen and shirts are not nearby, and so on. Now, the construction of the product space is not so simple. You can construct it in 2 ways. You can make the taxonomy tree, which is the time evolution of the tree, and you can make a slice at a given time that is the distance of products at a given time. While here, this is your ancestor, so to say. So we prefer this one for technical reasons. So it's not so simple. Finally, you can do, when you do it, it becomes very beautiful to see. This is Sweden, this is Sweden, a certain, not all, but a portion. Green stuff is where Sweden is very active, and red is not very active, small or zero. So size of spheres is the complexity of products. And now you see the state of Sweden in this product space is the big cluster of all the green stuff. And now, as we asked, if you have a point in this plan, fitness GDP, now you can ask, a point in the product space network is the old network of the green stuff. How will this evolve in the future? Okay. It is likely, for example, that it is more probable that you go and pick this guy, this red guy, and make it turn green, rather than this guy, for example, because here you have the similarity, maybe. But how do you do? Well, you learn what happened to all the others who have passed in a similar situation. So we look at all the guys who were in a similar situation as this, whether they pick this with the probability. And so for this, obviously, the space here is rather complex. So it is possible that nobody was exactly in this situation. So you have to make some similarity argument, machine learning tricks. So it's much more complex. This, I skip this complexity. But basically, from what happened to the others, how the others have grown, you try to learn how you expect to grow yourself. And how the others have grown, we can see, I give you an example. For example, this is Korea, how Korea has invaded the area of radio and other stuff, TV, typewriter, this sort of high-tech stuff. 63, only a little bit of radio, then was TV and something else, then more and more. As you see, you don't make jumps. So if you are here, you cannot go here. You have to go through this other part, and then you go here. So this means that our network makes sense, because if things would appear randomly, our network would not make sense. But it also means that if you make industrial policy and you are here, you better do it here and not here, because here wouldn't work. And as well, for investment, you better invest here and not here, and so on. So you see, this dynamics tells you a lot. Now, suppose you can know this stuff for everybody in the past, in the whole product space. So this is the information. It's a big information now. Then you can ask again the question where things will develop. And this is the answer for China and Brazil, for example. So we expect that in addition to the trajectory of the whole country, we expect that China will develop more in this region and less in others. So for example, we don't expect China to invade much more electronics just because it is saturated. We don't expect Brazil to go into electronics because it does not have the right capability. Okay, so different reasons, similar result. But for example, we expect China to grow more in machinery than in textile, and so on. So now this, of course, is a new information which can be used in many ways, industrial policy and investments. There is a very interesting analogy of what I told you with real ecology, because we have treated this stuff as an ecosystem, in a way, diversification, complexity, and all this stuff, but there are real ecosystems. And people have done the opposite. They have taken our algorithm for economic complexity and used it in real ecosystem, for example, plants and pollinators. Also, the matrix here is also triangular. There are actually data where triangularity is better. This is not one of the best. So there is a chance that this algorithm makes sense. And out of very detailed studies, this algorithm was considered the very best among all the network algorithms to find which species is the most important for the stability of the ecosystem, of real ecosystems. So this opens up a new channel of use of this type of algorithm in real ecosystem. And then the fascinating idea is that there is a close relationship between the industrialization, which is the explosion of GDP and of number of products that happened 2 centuries ago, with the Cambrian explosion, where most of the species on the planet have developed. So this now, given the analogy of the algorithm, the stability and so on, this seems more than a vague romantic allusion. It seems a reasonably concrete analogy. Finally, in the last minute or so, I tell you we are collaborating with Alibaba, and the idea is to analyze shops. Alibaba is the largest e-commerce in the world, and shops are different from companies, because companies make few products, but shops, if you go in internet, you want the whole catalog. So the more you have, the better it is. So again, you have the diversification is important for shops of Alibaba. And to make a long story short, okay, we have data from Alibaba, which again show triangular behavior. So we can analyze it with our method, and we get an interesting result that you see the fitness defined by our method for the Alibaba shops correlates with the income. And actually, there is also a correlation with diversification, which is what we would expect. So it seems that this story can be reasonably exported into the e-commerce in this way. Now, I would have a lot to tell you, so I forget for the moment. We'll see next. So finally, we have done countries. and products. We would like to do companies. For companies, we have patent data. I don't think it's that good for various reasons. We would like to have the trading network. So if you are a company and I'm able to know to whom you sell and from whom you buy, this is a trade network of real stuff. So if we have this trade network, maybe you can define how good you are as a seller and how good you are as a buyer with the different algorithms which we have not written. Okay, this is the challenge now to do. Now, this data, we are trying to convince Bloomberg, which in principle have data like this, but up in the last 3 months, I did not manage. So if you are friends in Bloomberg, please give a hand. You will be gratified. So, okay, as soon as we get this data, there's data by Standard & Poor's which are very lousy. There are Japanese data which are very secret. So in any case, that will be the frontier for us to get data and invent a new algorithm. Finally, I want to say this story has given us a lot of satisfaction, both scientific and business-wise, and I found a very open-minded view from companies and public policy institutions to collaborate, and I thank all of them, and in particular my collaborators and all of you who attended this lecture. Thanks a lot.
Hello. Yep. So we have time for quite a number of questions. Okay, I go with you first.
Ian Wilkinson, University of Sydney. Thank you for a fascinating, illuminating talk. I noticed in the last slide with the companies, you were looking at trading data. I know, having tried to play with that, I know how really difficult it is to get that kind of information and how it changes over time in particular. With your countries, you remain the country specific. The actual links between countries, fitness might be derived from those they import products to, and therefore indirectly they get fitness. Maybe that's covered, in the fitness will pick that up, I'm not sure.
For companies, you mean?
No, the countries. So
for countries
exporting or importing fitness from other countries.
Well,
So
okay, most of our work has been based on the export. We didn't care much for import, well, maybe we should a little more. But you see, the problem of import is, suppose you produce nothing, like some oil companies. When you have money, you can buy everything. So you see, it's less what you produce and you export. It means what you are able to do really. But if you just have money, you can buy everything. So we believe import has interesting information, but it's not so direct as the export. So if you want, for example, import has indirect information on the expression of this potential. Suppose I find that Thailand has a potential to export, I don't know, textile, okay? But somebody has to buy this textile. So if there is a general crisis in the world and nobody wants to buy this textile, even though you have a potential you cannot express. For the moment, all you have seen does not consider the second part. So I would say import is certainly important for the expression of the potential, for the concrete realization. How much you can learn from what you import, well, it's interesting, but I believe it's not exactly the question we have addressed, I would say.
Okay, but in your presentation, you make a prediction that, particularly about China, the electronic industry, your prediction is that may not be the next industry that China will develop, right? Did you make such a prediction?
I wouldn't put it this way. I would say electronic is saturated. You cannot do more than that in the water fraction. You see, it's different than what you say. I'm not saying it will not develop. It is the world leader of electronic manufacturing, and that's it. You cannot do more. It does already everything. Okay. You see, that's the position. So it's not, because that is the gradient. So if you are the world leader and you do half of what is needed in the world, you cannot expect that you will grow a lot in that area. It's already grown. You see, it's already totally explored area.
Yeah, the reason is that look like Chinese government recently plan to invest billions of dollars in, particularly in the microelectronic industry. So in that sense,
that's not different from what they say, because you see, you may not keep your position. For example, well, let me add some comments. All these analyses are relative. So, for example, today China is very strong in electronics. If they don't invest, it will go back, because countries where labor cost is smaller, they can begin to do it, and then they will erode the China competitiveness. So you see, not only China cannot grow, if they want to keep the position, I think they should invest, because competition from other countries is becoming more aggressive. So it is not in contradiction with what they say. What they say is that you cannot expect that China will do more electronics than what is doing now, according to us. But if you want to keep that position, you have to invest, because the others are coming up. You see, it's the same that all European countries, US, Japan, everybody of the top countries are going back. This I didn't show, but if you blow up the part of the most developed countries, which for us is the most complicated to analyze because it's very complex. So if you blow up that, all the fitness, even of Germany, which is #1, is going back a little bit, because China is coming up so strongly that the relative competitiveness is now smaller. So, you know, you built the same nice Mercedes today than you built 10 years ago or whatever, okay, more high-level machinery. But the fact that somebody else begins to be able to do the same thing means that building that same Mercedes makes you less competitive than before. So fitness is relative to your competitors. So if you do the same thing and you do it well, but the others are coming, your fitness is reduced. Okay, so coming to the Chinese government, if they want to keep that position and others are coming up, they have to invest, because it's a matter of competition. But our prediction of is that they will not conquer more areas of the market, simply because they have already a huge portion. Okay, that's.
Yeah, a question I want to ask is, what do we do about the missing questions? For example, my impression would be that the companies and countries that are on the right-hand side, that is with high fitness and making a lot of money, are also the drivers of inequality in the world, and also they're the drivers of climate change and pollution. How do we try and get a full picture?
What was your final change in?
Well, climate change in the world.
Climate change.
Yeah.
Okay. You go into questions that are beyond my capability. So, climate change.
Let me say, one of the reasons I'm asking this is we're beginning to see graduate students in a lot of universities in the world requiring that they be taught more about the social consequences of the economies.
Yes. Too difficult question. No, really, no. I mean, let me put it this way. This story has some limits. I mean, you say, given that you are very good and make little money, you make more money tomorrow. Very simple, okay. Now, the question is, in doing this, are you exploiting all the resources of the planet? Are you doing like the island where they cut all the trees? What is the Easter Island, whatever. The paradox of commons. Okay, that means that in addition to this information, you have to be reasonable, okay? So this is a piece of information. It's not God-given. It's a piece of information that you can use it, okay? So for example, what is good and what is bad about this information? What is good is that if things don't change drastically, namely the capabilities don't change drastically, for example, let me make a specific example. Corruption in Italy, okay? As you know, Italy is perfect, there is no corruption. But some people, they think there is a little bit. But suppose, okay. Now, what happened? Italy, after the Second World War, was probably in the upgoing countries very strong, where corruption is not important, okay? Now, I don't think corruption is very different. Probably was a little better reconstruction after the war. It makes you good feelings. But I don't think we were much better 30 or 40 years ago than now. Only now we are in a position where growing is very difficult, so all these things begin to matter. So there is a change in the importance, for example, of corruption. Because if you are today in like Vietnam, corruption is irrelevant for economics. I mean, I think those who are corrupted should go to jail. I mean, that's another story. But for economics, is not the fundamental element of suppression of the economy, okay? So this is an economic argument, it's not a moral argument, okay? But your story, you asked me a more complex question. You asked me, you know, what about sustainability of this stuff? Well, let me take the example in which there cannot be sustainability. Imagine that China is now going very up like Japan, in our view, okay? So this means that if you believe our story, in some years there will be 1 billion cars running with gas in China, which is impossible, okay? So clearly this will not go in that direction. So it is possible, however, that you make electric cars, that you may invent something else. So I think what is not in this stuff is a sudden change of capabilities. So like the paradox of commons, you cut all the trees, you have to watch that there are trees. So this story does not give you the answer to be sensible in that respect, okay? It tells you a little bit, I mean, what you can expect if you continue like that. But let me make a specific example of what you can do in positive with these arguments. We were asked by Shell to make a document with them for the government of South Africa. And so we studied this graph. Okay, this one, okay? Now, this is South Africa, blue, okay? This is it. Now, the idea is, what should South Africa do? Now, South Africa can go, if they want to do maximum money in the short time, they have a reasonable degree of specialization, so they can go up like this, okay, following Brazil and Russia. This they can. But as you see, fitness is decreasing. So if you want to try to go in this direction, which is the most developed countries, you should not do this. You should invest and go on the right at the expense of making more money, making less money on the short. So we can make these two scenarios quantitative, but then it's up to the politicians to decide whether you want to make money for yourself or for your next generation. You see the point? So we make scenarios and quantify them. The political decision is not in these graphs. These graphs permit you to know more what you can expect realistically if you believe them. But whether South Africa will decide to go along this line or to go along this line, this is a political decision, which we don't do, okay? So I think questions like ecology or sustainability, etc., are beyond this stuff. So this stuff makes you a little more comfortable with the information you may have, okay? But it does not give the answer to those questions straight.
Thank you for the great talk. I guess my question is slightly more mathematical in nature regarding the robustness of the fitness function. So how much of the definition of fitness does it depend on your choice of what constitutes as a product? For example, one could say a computer itself is a product, but you may divide it into desktops and notebook computers, okay, or the individual components can be treated as separate exports.
Yes.
And so there's many different ways of categorizing, and how robust is the measure to this sort of choice of categorization?
Yeah, we have written a full paper on this question. So the question is, if you have noise in the data, how this noise reflects into the results? So, okay, so it's a long story. I mean, actually, the nonlinear algorithm in this respect is more robust than the linear.
Oh.
Because the nonlinear is more robust because of this reason. Suppose that take nails, okay? And now, it is unlikely that nails are only done by Nigeria. It's probably also done by Ghana, by Niger, by others. So suppose that your you miss the data of Nigeria, it doesn't matter, the others will kill the nails anyhow. But if you have a linear algorithm, everybody counts the same. So in a way, it's very robust if you are in the good side. If you are on the bad side, where your information is less than 50%, which is clearly not the case, then it corrupts drastically. Right. But we have a specific paper, you can look up in the web page if you are interested, but this is a question we have posed, which is how noise in the data reflects into the results.
Great, thank you very much.
Thanks.
Thank you. Retrospective analysis is always wonderful to be able to do. I just wondered if you had done any retrospective analysis, taking this data but going back and perhaps looking at two areas. One would be shock, financial shock, such as what would the picture look like before Lehman, and then what would the picture look like after Lehman? And looking at Russia, for example,
after Lehman,
yeah. Global financial crisis, Lehman collapse, and also for Russia particular, you know, what's happening with Russia now, given the shock of the oil price and the fact that their fitness has been going backwards? Does that mean that they've had a bigger reduction than would necessarily have happened doing other analysis?
Mm-hmm. Well, this, I mean, finance is reflected only with respect to the influence that finance has in real economy, because this is a real economy thing. So clearly there is an effect. I don't have here the specific data, but you can see, right, here you cannot see much because these are very rough pictures. If you do a fine analysis of that, well, you find that there is a decrease of production and then there is an increase again. Most likely, the countries with high fitness are faster to go to recover. For example, this is I don't have the specific stuff, but basically, finance is an independent element. So you only see it through the loss of production.
So fitness does then reflect the ability to recover shock.
In a way, yes. I don't want. This was my feeling. Yeah, I don't want to make this strong. I have the impression, so I mean, I looked only one picture and I had this feeling, but it's a good question. We should take more care. I don't know. It's reasonable. I mean, from one picture, that's what happens. So it's.
Hello. Thank you very much for the talk. It's great to see these vector diagrams. My question is, how does the pie grow? So you've defined fitness in relative terms, as you've made mention multiple times about its relative rankings. But for example, that GDP per capita is an absolute sense. So everybody could theoretically all do better, right?
Yes.
The global economy could grow.
Yes.
And I didn't hear anything about the concept of there are new products, right? So 100 years ago, electronics might not have been a product category. And so those countries that are in the upper right that might have some difficulty could move into new spaces that don't exist yet. How do these possibilities relate to your analysis?
Yeah, thank you. Yeah, very nice question. So first, is the world overall improving? Well, we have decided to normalize things every year. You may not take this decision. So for various reasons, this is a convenient position, okay, to consider everything relative. If you want to pose your type of question, maybe you should not do it, and you can decide not to do. We decided to do it for technical mathematical reasons. So yes, this is something that one can pose. But on the other hand, you know, okay, for the money, it's clear what it means, even though it depends also what you buy with if you have more money, so it's not obvious. But see, the fitness is intrinsically your level of competitiveness with respect to the others. So I think the normalization is natural somehow. Maybe not, but I mean, you can decide not to normalize and then you have something growing, okay? But then you get pathologies and so on, the math becomes a little more subtle. So anyhow, it's a good question, I don't have a good answer, okay, for the first. Now, second, products grow, sure. I mean, there are new products. In fact, I've cheated a little bit when I showed you this, because over the years, not only some spots may become green, but some new spots may add, like you say. That's why I say this stuff for doing the broader space is not so simple as it may seem, that the pencil and pen, because you have two problems. One, the occupation of the given space, the fact that the space itself grows, okay? So all I've told you is pretty reasonable for the occupation of a given space. But even our data, change over the years, because we have 50 years of data. And so the products are not always the same. And this poses various questions, okay, that I've a little bit overlooked. But the very challenging question you pose is the innovation. I mean, how do you decide that there is a certain probability that Google appears or not in a certain region where it is not? Okay, this is another question beyond all I've said. We are considering this question, but it's pretty difficult. So, for example, you can say, if you have a dense region of products, it is more likely that from there a new one appears, or if you have a more sparse region, stuff like that. For example, we would have had a hard time to tell you why Nokia has appeared, okay? But I can explain you why Nokia has disappeared. Why? Because Nokia has appeared by a random fluctuation of a few genius engineers, okay, that we cannot predict. But when you had the transition from the cell telephone to the smartphone, namely when you have something in your pocket that does 100 things in addition to the phone call, then Nokia was not in a region with all that competencies, to have, I don't know, GDP, whatever, okay. So it was natural that this in Finland you could not sustain, to have all these new competencies, and that California was the right thing. So I can tell you, Nokia suppose is a very isolated thing like this, then if the market grows here and this becomes a big market of many other things, so it becomes a new object with many links to other products, that is the change from telephone to smartphone, then Finland is not the place, okay? So we can understand why that was critical, but we cannot, you see, the production, the burst of something is very difficult to predict, the burst of something from scratch. Certainly you can say, given some environment, this is the same as the, for example, analysis of startups. Startups, few percent survive, okay? So it's a very small probability, and there are big studies on this. Innovation is the same problem. So this is very hard. We hope to be able to address these questions, but basically at the moment they are beyond what we can do.
Okay. Let's thank Professor Pietronero again. Coffee is ready, but before we go leave this room for coffee, let me present a token of appreciation for Professor Pietronero. We'll go.
Thank you.